So that is the general function of exponential function. The first translation is going to be Hanazono shift, and the second will be the reflection. When I say reflection, if the negative is on the x, you're going to reflect over the y-axis, meaning you have a decaying graph. If the negative in front of b, say -1, so a will be like -1, a will be -2, you're going to flip over what? The x-axis, right? Reflection, let's say flip over the y-axis or flip over the x-axis. Well, the y-axis, that's your decaying graph. And remember, when do I flip over the y? When do I flip over the x, right? Here, flip over the y-axis. If you have something like this, f of negative x, and you have negative f of x, then you flip over the x-axis. The third one will be vertical stretch. What I mean by vertical stretch? Remember, I told you how fast the function grow depend on the base, right? Either the function get really steep, or it's kind of chill, kind of grow, but not as fast. Steep versus not too steep. This is not textbook stuff. I didn't write it so you understand it. That's all. Number 4 will be vertical shift. That will be the last one, always the last one, vertical shift. -3 to the negative x plus 1 minus 2. It has everything. So the first thing first, what should I do? Yeah. Well, the base 3, nothing. Before we do shifting, what should I do? Yeah, we factor the negative out for the x, right? So equal -3, and then I factor that -1 out. So become minus quantity of x minus 1, and then -2 in the bottom there. So that's the first thing first. All right, let's do some shifting. Step 1, it's gonna be what? Yeah, let me do it like this. Vertical. We horizontal shift, and then reflection, and then vertical stretch, and then vertical shift. All right, horizontal shift will be what? It's gonna be right one, right? And then reflection. How many kind of reflection do I see here? 2, right? I have a negative on the x, and I got a negative in front of the whole function, which is negative in front of 3. So I'm gonna reflect. You know what? Let me do yeah, this is fine. So it's gonna be reflect over the x-axis because what? Because of the negative x minus 1, right? So reflect over y-axis. Of course, you don't write things down like this on the exam. I'll just write out my thought, that's all. Vertical stretch. Is there a vertical stretch compared to y equal 2 to the x? Yes, right, it gets steeper, right? It gets a little bit steeper. Slightly steeper compared to y equal 2 to the x. My vertical shift will be down 2. And my horizontal asymptote here will be what? Y equal negative 2. Did you remember that? Let's graph. I always start with the basic graph. Right, the parent graph here, I'm gonna take y equal 3 to the x. Just imagine that's y equal 2. You can do y2 to the x, doesn't matter. Your real graph will be slightly steeper than that. It's, the exponential graph always go through 0, 1. Remember that part? That's where you shift. That's where you use that point to shift. Right 1. So like that, right 1. And instead of going, you know, my bad, hang on. Sorry. I say y equal 3 to the x should be exponential growth. Shift right 1, and then reflect over the x-axis. Reflect over the y-axis first. Because it's the negative x. Remember your original problem is the negative x. It's gonna be decayed, right? So it's going like that, right? It's decaying. Don't write this down. It's just I'm gonna do in dash because it's not your real graph yet. You can see, no, you can't not see that, sorry. You can see a little bit better. Yeah, don't draw that down because it's not your final graph. Because the negative x, right? And now what? Because the negative in front of the 3, you're gonna reflect over the x-axis. You're gonna flip it. So it looks like this. And the point, the blue point right there, is gonna go down here. It's gonna be 1, negative 1. Flip. Right? And then the last one will be what? You dragging down 2. 1, 2. So your final graph is right here. My horizontal asymptote is y equal negative 2, which is makes sense. That's y equal negative 2. And you're gonna give me the coordinate of that blue line, the big blue, negative 1, negative 3. So I'll give you a grid. Yeah, I just want to show you the steps of the translation. All right, so that's last time. Move on to today's lecture. We still on exponential function. You guys all know pi, right? What is pi? Give me the definition, not 3.1415. Give me the definition. What is pi? How can I write pi? What is the circumference of a circle? 2 pi r. Now I can solve for pi, right? Pi equal, if I divide both sides by 2r, let me c over 2r. Don't write this down. Nothing to do with your exam. 2r is the same thing as r is your radius. So 2 times radius is equal diameter. Right? So pi is a ratio between circumference of a circle and its radius. I'm sorry, and its diameter. So that's the definition of pi. It's a coincidental number. It's rational. So you cannot express pi as as 2 number, but it's in the ratio of a circumference of circle and its diameter. Same thing, E is the same thing. It's another transcendental number. Right? It's go on forever without stopping, without pattern. So it's similar to pi in that sense. Now we have an exponential function. We call that a natural exponential function. Have a form y equal e to the x. E. Pi is 3.1415, etc. Right? What is e? It's in your calculator. You can just pop it up in your calculator if you want, right? Say it again. Like pi e has its own formula, and its formula is 1 plus 1 over x to the x power. Now let's plug in some number for x. Say x equal 10. I got 2.5, 9, 3, 7, etc. Let's increase it by a factor of 10. Say x is 100. I got up to 2.7. Let's increase it into 1,000. 2.71, 10,000, 100,000, a million. What do you see? It's kind of stop it right where? It's kind of stop it at 2.7 something, right? So if you put like a trillion here, it's still 2.7 something. So as x approaches infinity, that function right there approaches 2.718 something, right? And then it's just kind of stop at 2.7. So that's your e approaches infinity. Your y equal 1 plus 1 over x to the x is approaches 2.718, etc. Oh, you know what? Hang on, guy. There's a bonus extra credit question. Go ahead and do that. Go ahead and do that. Oh, there's no bonus question yet. Let me check. No, not yet, not yet. I'm sorry. My bad. No, not yet. Later. So E is 2.718 something, right? It's in your calculator. You can have it. Because the base is bigger than 1, so this is going to be exponential growth, right? So it still have that increasing curve. So that's E. We'll come back to it. Right now, let's solve some equation, exponential equation. There are two types of exponential equation. The one I'm showing you right now is the easy one of the two, right? And I'll tell you why it's easy. Let's solve this one. My step one, I'm gonna write both sides of the equation with the same base. So let me rewrite the left-hand side. 2 to the 3x minus 8. 2 to the what power? Give me 16. 2 to the 4. 2 to the 4. That's what they meant by write both sides of the equation with the same base. If 2 to the 3x minus 8 equals 2 to the 4, because you have the same base, by logic, if they are equation, then the top should also be equal, right? So this implies 3x minus 8 must be equal to 4. And then solve. Add 8 both sides, I have 3x equal 12. And divide both sides by 3x equal 4. That's what I meant by easy of the two, right? All you have to do is transform those two sides have the same base. You can drop the base, let the top equal to each other and solve. You can check, you can plug x back. 4 times 3 is 12, 12 minus 8 is 4, so 2 to the 4 equals 2 to the 4. Solution checked. All right, this one will be slightly more involved. I'll be very helpful and I'll transform the 27 to 3 cube. You gotta do the left hand side. Let's use black for now. Anybody? 1/3. No. How can I transform 1/3? 1/3 is not 3. They are reciprocal. I need to rewrite the 1/3 becomes into a 3. Yeah. Yeah, right. Remember this. Remember this. If I have a over b to the n, I can, if I flip the fraction inside, my exponent change the size. Right, change the size. So it's going to be 3 over 1 to the negative 2x minus 3. Remember, the negative is for both of those numbers, right? Not just for the 2x. That would be your n. That's block right there is your n. Well, 3 over 1 is the same thing as 3, yeah? Now let me distribute. And now I can drop the 3, and I'll tell you why we drop it later, formally. But right now, just drop it. So now I can set the exponent equal to each other. I distribute the negative at the same time. Two x equals 0, x equals 0. Makes sense, right? You plug in 0 for 2x. I'm talking about the original problem. 2x becomes 0. So 0 minus 3 is minus 3. 1/3 to the negative 3 is, yeah, it's the same thing as 3 over 1 cube, right? Which is 27. check. This one. This one a little bit hairy, but if you remember your exponential rules, you'll be fine. Well, nothing I can do for the right hand side. That's base E. I need to transform the left hand side into just one E. Right now I have two E. Remember, I need blue, I'm talking about the one I highlight in blue. If I have a to the n divided by a to the n, of course they have to have the same base. The quotient becomes a difference, right? So it'll be a to the m minus a to the m minus n. Makes sense, right? Look. This is a to the m times a to the negative n, right? Well, you have the same base, you just rewrite into one base by adding the two exponents together. So n plus n minus n, which is n minus n. So how would I rewrite the one I highlight in blue? E to the x squared minus 3. And then outside will be 2x minus 3 equal e to 2x. Well, you know what? Let's. You don't know how to solve the cubic yet. Let me fix it. No square. No square. It's lagging terribly. So let me remove the square for you. Make it your math easier. If I have a to the m raised to the another power n is equal to what? A to the m times n. So that means here is going to be e to the x minus 3 times 2x minus 3 equal e to the 2x. Now you have the same base, you can cancel it. You let the exponent equal to each other. Extra credit. All right. 2x squared minus 3x minus 6x will be minus 9x plus 9 equal 2x. You can FOIL out slowly. 2x squared. I'm going to move everything to one side because it's quadratic. Minus 11x plus 9 equals 0. Can you find two number multiply to 18 and add to negative 11? Product is 2 times 9, which is 18. And the sum is negative 11. Is it such two number? Not two? Oh, negative, yeah, negative 9, negative 2, right? you can remember how to solve, how to factor this. So this means 2x squared minus 9x minus 2x plus 9. Group them together. The first group I can factor out x. So 2x minus 9. What should I factor out for the second group? -1, right? So 2x minus 9 equals 0. Two x minus 9, 2x minus 9, factor out again, 2x minus 9 times x minus 1 equals 0. This implies what? Either 2x minus 9 equals 0 or x minus 1 equals 0. And then you solve for x. So x equals 1 here, and then x equals 9/2. And that's just quadratic. Imagine I give you cubic, which I won't, I promise I won't. Last one, and then you can do your bonus extra credit problem. Oh, there are 2 of them. Which one I gave you? Oh no, it's fine. Why don't you do this one? I'll walk around. It's not your extra credit, but do this one. I want to see how you do it. Thank you, Sophia. Half of you did okay. This one I got it right. The other half, not really. I think because you forgot the rules. If I have a to the m times a to the n is equal to a to the m plus n, right? So actually, you guys got it wrong. All of you got it wrong. So this one becomes what? 2 to the 2x plus 1 plus -3, which is 2 to the x minus 2. And then drag that right-hand side down, which is equal to 2 to the x minus 1. Now I can drop 2x minus 2 equal x minus 1. Subtract x, add 2. Oh, all of you got it wrong. Oh, 1, sorry. I don't know why I say 4. 1, so -1. Thank you. Ah, darn, yes. With positive one. Maybe we should have write out step. Yes, write out step. I'm not taking an exam, I can make a mistake. So what you guys did wrong here, so what you got it wrong there was you multiplying 2x plus 1 with -3. If I have a to the m, raised to the n, and yes, I multiply. What's the difference between the two formulas? How many bases you have in the first one? 2 bases, right? 2 same bases. And then the bottom one, you only have 1 basis, and you've been raised to some other powers. So be careful. And you can check. Let's check, put 1 back there. So 2 times 1 is 2, 2 plus 1 is 3. So 2 cubed is 8, yes? Yeah. Do you guys remember what section it is? Like a bunch of rule I put on there. I forgot what section. Yeah, it's the other line. Go back up on the slides. Yeah. So 2 cubed is 8. You know what? Just let's go ahead and leave it as 2 cubed. Times 2 to the -3, right? And then you add them together, because this is equal 2 to the 3 plus -3, which is 2 to the 0, which is 1. Right? Let's check the right-hand side. You plug in 1 there. 2 to the 1 minus 1 is 2, 0 again is 1. Right? So check. Last one. This one is hard. This one is kind of hard. I'll do it with you. Right, 2 to the 2x, nothing I can do there. I see an 8. I'm going to transform 8 into a 2 to something. So 2 to the 3rd. Very good. Just one step at a time. Can I combine these two? 2 to the 3rd times 2 to the x becomes 2 to the. No, you're not multiplying. Remember the rule. Yeah, remember, careful the rule, right? If you see 2 bases, you're gonna add. If you see 1 base, and then you have 2 power, you multiply. So this is 2 to the 3 plus x. So x plus 3 doesn't matter. So 2 to the x, 2x minus 2 to the 3 plus x plus 16 equals 0, and I'm stuck. You know I'm stuck. Hmm? No, no. You stuck. You stuck. You know, I have a better idea. Sorry about that. Erase it. If you stuck, you just one thing about mathematics, right? You stuck, you get your hand dirty, you can get your hand dirty, right? You stuck, you find other way. Don't write this down. I'll tell you when I'm stuck. What I'm gonna do next? Nothing, right? There's no rule that I'm allowed to combine the two together because between them are plus and minus, right? Not multiplication or division. So I know that I'm stuck. So that means what I'm doing here is wrong. And that's okay. You find another way. Let me tell you this. If I have a to the 4 plus a squared plus 1 equals 0, for example, can I rewrite like this? A squared squared plus a squared plus 1 equals 0. Can I do it like that? Yeah. And I'm gonna let, don't write this down. I'm gonna let a squared equal b. I'm gonna replace everywhere I see a squared, I'm gonna substitute for b. So this becomes what? B squared, right? Plus b plus 1. B squared plus b plus 1. Quadratic. Right? So that's called quadratic form. We're gonna do the same thing for this problem. Maybe you don't see it, but let me rewrite it for you. I'm gonna rewrite 2 to the 2x as 2 to the x and then square. Minus a times 2 to the x. Put a parenthesis like that. Plus 16 equals 0. I'm gonna let 2 to the x equal u. So everywhere I see 2 to the x, I'm gonna replace with u. So that means what? U squared, right? That's become u squared minus a times u plus 16 equals 0. Can you solve for this one? So far, so good. Do you have any question up to this point? You do, please ask. What number multiplies 16 to x to negative 8? Mhm. Thank you, Mike. So this implies u equal 4 or u equal 4 is the double root. Okay. Now, am I solve for u or solve for x? Solve for x. Now you start out with x, you're gonna finish with x. So I'm gonna substitute it back. In the beginning, I let 2 to the x equal u. Now I'm gonna replace u with 2 to the x.